I'm Michael Maloney, founder of Satellite Design for Recovery.
I am Jason Aspiotis, founder and CEO of Finsophy.
I'm Ralph Dinsley, known as Dins. I'm the executive director and founder of Northern Spaces Security.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
Each facility will house hundreds of people. And of course, the idea is to have most of those people as being paying tenants. But we will need to have people who are growing food, because we're not going to be importing food. We're going to be growing everything that we need to eat and sustain ourselves. We're going to be recycling everything. So, you know, you're going to need people there who are going to be growing things and fixing things and maintaining things and helping, you know, the tenants and their needs. So there are going to be staff on site.
Welcome back to the Cold Star Project. I'm your host, Jason Kanigan, the founder of Cold Star Technologies, a data science and process improvement firm. That means we make good companies run better. And I'm here with Bill Kemp. He is the CEO and founder of United Space Structures. And I wanted you on, Bill, because we ran into each other and started talking about the business model for USS. And I think it's really, not only is it cool, but it's thinking big, it's necessary. Somebody's going to do something like it, and why not you and the team that you've got? And I want to be able to broadcast great ideas with this show. So that's why you are here. Thanks for being here.
Thanks, Jason. I appreciate it.
All right. So folks who don't know Bill, he has a pretty good background in a number of technical areas. His education is in interior architecture, which, you know, turns out to be pretty important on the thing that we're looking at here today. He has designed 34 tier 4 data centers. So there's a lot of brain power here. Some research facilities, command centers, hospitals. You've been an architectural designer and project manager for these things. And there's a phrase here, mission critical multidiscipline engineering, architectural designer and project manager. That adds some weight to it, doesn't it, when you say mission critical? So let's dig into what you are trying to accomplish here with United Space Structures. What's the gist of the idea?
Well, United Space Structures, USS, is a real estate development company. We're going to be designing and building the facilities on the moon initially, and later on Mars. But it's very much a real estate development project in that we're going to own, operate, and lease out space within our facilities to a variety of different tenants who want to have access to the moon for a variety of different reasons.
Excellent, and that's the short version. There's been a lot that has gone into this. The more I dug into it, the more I was like, okay. And you and I have talked for about an hour or something like that beforehand to get into the details here. So a lot of space founders that I've talked to before running into you would have approached this purely from the technical aspect, right? We want to do something cool and let's build a structure or something like that. And you've approached it with the business model in mind first, which is, I think, the proper idea. So tell us about lunar infrastructure is kind of the technical means to the end here of providing that. Tell us about the structure. What is it going to look like?
So the structure is actually built within a lava tube. So it's underground. We chose that intentionally because the problem with space is radiation. You know, people worry about high velocity projectiles, and that is a concern, but it's not as big a concern as solar or gamma radiation from the rest of the cosmos. So we wanted to build it underground so that we had at least 30 to 50 meters of regolith over our head to protect us from that radiation that's constant and never ending. I mean, even in a lunar night where the sun's not directly shining on the moon, you still have radiation coming in constantly. So we wanted to build within the lava tubes, and we wanted to build something that was something that our robotic systems could build semi-autonomously. We're going to be teleoperating them from Earth, but you know, they need to be able to do the construction process without human intervention on the ground. So we chose a rather simple and strong structure, and that is a cylindrical high-rise structure that goes from the floor of the lava tube all the way up to the roof of the lava tube, and creates a very large structure. And when I say large, I mean it's 188,000 square feet of pressurized space within a 25-story structure.
Mm-hmm. Yeah, this is enormous. That's what I really like, the robotic idea. I love the thinking big, and I love that it's not an inflatable. I think that would be a more dangerous way of doing it. So you're creating kind of a stand inside the lava tube and making this sort of wattle structure around that. How would you describe it?
Yeah, so it starts on the surface, and we're gonna drill down and
Mm-hmm.
create essentially our center core, which will be our elevator shaft and stairway, and where a lot of utilities are gonna go. But we need to drill through the regolith and create an entry. We could potentially go through what they call a skylight,
Yeah.
for the lava tube, which is an area that's already been collapsed. And we figured that that's probably not a good reason or place to go, because it collapsed and it was not a strong
Yeah.
area. So we want to find a strong area, and then we're going to drill down into it. And then once we do that, we can start to build our tension structure within the structure, within the lava tube.
Okay. So what sort of technical things do you need to have in place to be able to do this? Because this interview is going to go on the Moon, Lunar, and Martian Construction ISRU playlist for the Cold Star Project. And so if folks want to understand more about the problems and dangers of working on the moon, the regolith on the surface is extremely sharp. It tends to cut through filters very quickly, or I can't think of the thing that
Joints?
I'm thinking of right now. Yes, gaskets was what I was thinking of, but yes, exactly the same sort of thing. And it is not what you would call a friendly working environment. So, in order to produce at scale here, what sort of things are you going to need to get to the moon, to drill down, to create this structure inside?
Right. So, yeah, the surface operations are going to come into contact with that a very abrasive regolith. But once we break into the lava tube, then the lava tube is relatively smooth and hard and doesn't have any of that abrasive material that is found on the surface. So our equipment down there will not have some of those issues with that material. Now they have other challenges. We need to be able to design and build our robotics so that they're robust and can deal with time delay, 2.5-second time delay, round trip signal, so that they can do what they need to do. But the elegance of our system is that it's rather simplistic, and the construction process is sequential. So, we're going to do a certain task, and once that task is completed, then we'll have a different robotic system that does the next level of tasks. So it's just a matter of building the system robust enough, not only to build the first station, but once we have the first station up and running, people occupied there, miners mining and processing that material into finished goods, then building the second and the fifth and the 10th facility with that same robotic equipment is going to be really important going forward. So we want to build it robust enough to be able to build more than one facility at a time.
Okay. Yeah, and of course the big challenge in anything like this is the 0 to 1, getting the first one done, improving the concept. If you look at something like a boring machine, like a tunnel boring machine, those things are massive. What are you going to require for drilling down from the surface?
So yeah, that's boring machines are generally built to bore horizontally. We're
Drilling,
boring
yeah.
vertically. So, and we, even if we are able to secure like SpaceX Starship, which can carry up to 100 tons of cargo, supposedly, eventually. You know, a boring machine is really massive. Now, the hole that we want to bore is about 20 feet.
Mm-hmm.
And so it's not as big as, you know, a lot of these boring machines tend to be, but it's not insignificant. And so we need to design it so that it's relatively low in mass and small and modular, so that it can be assembled on the site and then operate so that you know it can do its task, you know, while we're operating it from Earth,
Mm-hmm.
without, you know, getting caught up and stopping operations.
Mm-hmm. And it's probably going to be able to, it's going to need to be able to at least fix itself in some way, because you're not going to have a human operator there to pop off parts and put in new bits or something like that. So
Right. We'll
that's
be
going to be
monitoring
interesting.
it with
Mm-hmm.
video and other sensors and things like that, and we'll anticipate, you know, things that could bind it up
Mm-hmm.
and prevent it. But you know, you never know until you actually do it. And we'll run tests here on Earth
Mm-hmm.
to simulate that process, so that we're not, you know, going up there totally blind.
Okay. Bill, what does the marketplace need on the business side here that you've identified that says, okay, yes, we should go do this?
Well, you know, everyone's racing to the South Pole of the moon, and for good reason. That's the first place we wanted to go, but there's no lava tubes down there, and our architecture is dependent on lava tubes. So, you know, everyone's going to the South Pole because they want to mine the water in the permanently shadowed craters, and then use that water for either in space human use, or to break it down into hydrogen and oxygen for rocket fuel. And so, you know, that's just a resource that's needed for the space infrastructure that, you know, will allow us to all expand into space, right? You have to, once the explorers come back and tell us of the riches of the unexplored area, then the next people that come into place is the people that build the infrastructure that allows expansion into that area. You know, you can think of it as like the railroads,
Mm-hmm.
you know, United States, where, you know, we needed to be able to move large amounts of people and products and things across the country. And so you had to build a railroad system or a telegraph system to be able to do all those things. Well, gas stations are the same thing. You know, you build the highways, you got to build a gas station.
Mm-hmm.
So building infrastructure is really the next big thing. So what is the moon? The moon is an unoccupied space that has many, you know, treasures of minerals and metals and things like helium-3 and water. And so it has lots of basic building materials that are needed in order to build out that infrastructure. And so, you know, it makes a whole lot more sense to go to the moon and mine and put those things into orbit, in that you know, it has 1/6 gravity of Earth.
Mm-hmm.
You would only be able to, for the same amount of energy, you can put up 6 times more mass into orbit from the moon than you could from Earth. So economically, it just makes sense. So if you want to build the infrastructure of the space, of expansion into space, then the moon is the closest lowest hanging fruit. Now, obviously, asteroids is better as far as the delta V, but they're further away and more complex, and so the moon is, you know, the next logical space.
Right. Well, who do you anticipate will be tenants then in these facilities that you'll be opening up and leasing?
So obviously, you know, if we're looking for, you know, mining resources, we need lunar miners, right? So we're gonna talk to, and we've already talked to several mining companies here on Earth that are massive, and some of them are small, but, you know, they're creative and they know how to mine, and so they're going to want to be able to mine the moon, and they're going to need access to the moon. So it's better to give them a safe haven in our facility, so that they can teleoperate within the comfortable but local confines of our facility, and then they can go out on the surface if needed to be able to go and repair or fix or analyze what's happening in the field. So lunar miners is probably the easiest one to understand. Then, my background is data centers. So the computer internet system has exploded in the last 20, 30 years. And, we couldn't do what we're doing right now if we didn't have that. And that's going to expand out into the solar system. So we want to build data centers within our facilities, not only for the research and development that's being done on the moon, but also for clients on Earth that want to have ultra secure data storage or processing that is uninterrupted by anything that's happening here on Earth. So there's a variety of different tenants that we can use, and that marketplace is only going to grow exponentially eventually in space. And so we want to have those data centers in place to be able to start doing that work.
Okay.
Beyond that, you have tourists, and tourists are going to, who wants to go to the moon and stay on the moon for a week? I mean, nobody's doing that now. So, how would you like to be able to do that?
All right. So several different potential income streams. And I do like the getting rid of the 2-second delay, secure data. Who's going to go to the moon and mess with your data center, right? It's a bit out of the way. We don't have to deal with hurricanes and that. I was business development manager for an IT firm quite a while ago. And off-site, out-of-region data storage was important for companies who wanted to avoid hurricanes and earthquakes and fires and things like that. And obviously the moon is pretty safe from a lot of those things.
No hurricanes on the moon.
This is Jason Kanigan from Cold Star Tech, and I'm excited to share with you a new offer from Cold Star that we are bringing out to help both space founders and venture capitalists who fund space companies. And it's on 2 levels. The lower level is a VC who is looking at possibly funding a space company, but they just don't get it. All right. And a lot of tech founders want to come out and create some sort of technical capability, but they do not understand business. And so you'll look and you'll go, where's the customer here? Where's the business model? And they'll go, but I want to make rockets or something, right? And it's really cool. Well, that, as we know from the dot-com era, is not a viable business model. And so you bring us in. We've got great technical expertise on the space side, folks who have done this sort of assessment before, like our technical engineering advisor, Dr. Rick Fleeter, myself in the process engineering field, plenty of other people with brains to look at this problem so that you don't have to blow your brains out trying to figure out how to make this work. And on the company side, it's a benefit for them because we will show them the roadmap to how you're going to get funded, how you will want to fund them, what changes to make to get VCs excited about putting money in. And so that's good for you. Right? The second level is at a deeper and higher level at the same time. It is for venture capitalists who have given a seed round to a company, a space company, and that has gone on for a little while, 6 months, a year, something like that. And it is time, as COVID has made it, to double down or get out. Those are pretty much the choices, right? It's time to invest further in a thing we already know, which seems to be the direction VCs are going in right now. They don't seem to want to look at new things or stop, just kill the project. And so the good news is, in that situation, there's a lot more going on. There's more meat for Cold Star experts to get in and analyze, right? You're going to have processes in place, whether they know it or not. We'll be able to flowchart those and maybe accurately document them for the first time so we can get some kind of value chain going in the organization. We'll be able to test whether the leadership is the right group of people or whether you're missing something, the strategic direction, the business model, all this stuff. So if this sounds interesting to you, reach out to us. You can email me at jason@coldstartech.com or just connect with me and message me on LinkedIn. That's probably the best way to do it. And I'm excited to talk to you. The kind of transformation that we're able to offer here is beyond anything you'll see out there. And as a VC, this will save you so much time and energy, right? Like if you're a VC and you've got 100 companies to look at, you've got 3 days a year to look at each one maybe, right? That's not really good enough, is it? Wouldn't it be better to have experienced, expert space people who understand space, right? Look at this investment and tell you, here's a grade, right? Here are several grade areas. Is this thing ready to pour gasoline on the fire, or is it just going to go up in smoke? This is Jason Kanigan from Cold Star Tech. Let's get back to the interview.
What kind of budgets are we looking at? What kind of pool of money do you require in order to get started with this?
So in order to get started, like any other architecture, engineering, construction project, you have to design it. You can't just go and build it, without knowing what you're building. So we have a 6-year design, research and development project, not only to design the architecture and the engineering systems that support the architecture, but also the robotics that are going to be building the architecture. So we have 6 aggressive years of research and development that we need to do first and foremost. And that's going to happen in phases. And those phases are going to be anywhere from 12 to 15 months long. And so the first phase is only about $2.64 million. And that'll get us, to schematic design phase, which will define a lot of the requirements and things like that. But overall, we're currently projecting the total cost for the very first facility to be in the neighborhood of $1.56 billion. Now, that sounds like a lot of money, and it is, but if you look at, a professional sports arena, football field, something like that, or if you look at ocean lining cruise ship, those cost about $2 billion each. So it all boils down to, its cost and then its benefit, or the ROI, return on investment.
Right.
And,
which is my next question.
We think the ROI is going to be very attractive.
Hmm.
And 1.56 is a significant amount of money. But if you have a facility up and running, here's the important thing I think most people need to understand. While the first one is 1.56 billion, the second one and everything after that is going to be significantly less, because we've already amortized the cost of the design and the robotics and their construction and so forth. So that cost gets spread over many, many, many different facilities that we're going to build. So actually, if you look at it in aggregate, each facility is going to cost hundreds of millions of dollars each, not much more than that. So that's unheard of for a lot of people, but you just need to think broader and deeper.
And longer term, once again,
Yep.
this is something that's going to take multi-year, probably the better part of a decade to get up and running in that. How many, do you have an idea of how many people you're going to have to employ as operators on the moon who are physically there, or is it going to be 100% teleoperated back with that 2-second delay from here on Earth?
Well, for the construction phase, it's all going to be teleoperated. So we'll have operators in a command center, working the robotics and guiding and helping them along the way 24 hours a day, 7 days a week for up to 2 years through the construction process. But once it's built or built to a certain phase where we can then send humans there, and you have a pressurized structural habitat to work in and build out the rest of the interior of it, then that can happen relatively quickly and easily in shirt sleeve kind of environment. So that's our thinking right now. Once the facility is up and running, it's each facility will house hundreds of people, and of course the idea is to have most of those people as paying tenants, but we will need to have people who are growing food, because we're not going to be importing food. We're going to be growing everything that we need to eat and sustain ourselves. We're going to be recycling everything. So, you're going to need people there who are going to be growing things and fixing things and maintaining things and helping, the tenants and their needs. So there are going to be, staff on site.
Okay. And do you think dozens of people or a dozen of that core staff? Just trying to get a mental picture.
Yeah, it really depends. You're going to need,
Mhm.
N+1 redundancy
Mhm.
for certain critical things like, engineering staff. You're going to need, an on-staff, electrical engineer, mechanical engineer. Uh, you're going to need roboticists that are going to be assisting the tenants with their robots. You're going to need a variety of different things. You're going to need a
Mhm.
medical staff,
Yeah.
able to have hospital, operating room kind of capabilities because, it's a long way home if you have an accident. So you need to be able to take care of medical issues, and so there's a lot of things that we still need to determine,
Mm.
but the staff could be 20 to 50 people out of 5 to 700 people within the total facility. So time will
Okay.
tell.
Yeah. Yeah, 'cause the factory designer in me, which I'm trained in, is kind of excited about this because it's not enough to just build the box, right? You need to put the machines in it in order to get the end result here. So, and you need to do that. You can't just say, okay, here's the space, you guys fill it. There has to be a certain minimum level of infrastructure in there,
Right.
machine shop, medical, things like that, in order to be able to make and repair and heal human beings and feed them. So.
Yeah.
That's pretty neat. How many facilities are you thinking about in the initial bunch of these? We may have covered that a bit already,
So
but let's recover it.
yeah, we've identified 3 sites on our website, 2 on the front side and 1 on the back side. And we want to build uh, facilities in each of those. Now, lava tubes can be tens of kilometers long, and our footprint within the lava tube is only 100 feet in diameter.
Hmm.
So we can potentially put hundreds, if not thousands, of in each of those lava tubes, and there's 62 known lava tubes on the moon. So we can build a lot. And once you have the equipment and manpower and the energy sources and all that, then building subsequent systems are going to be faster and easier. Most of the materials, even for the first station, is going to be lunar derived. We have a waterless cement system, which will be the majority of the mass. Certain other elements are going to be brought from Earth, but a lot of it's from there. And after the first station is up and running and we have manufacturing going, then we'll be able to develop 95, close to 100% of all the mass needed for those stations right there on the moon. There's certain things that you can't get on the moon, like nitrogen, which is
Hmm.
what we're all breathing right now, mostly. So, but oxygen, there's plenty of that on the moon. It's 40% of the mass of the moon is oxygen. So that's not a hard thing.
Right. Yep. Carl Sagan was one of the earliest people in my childhood to remind us of the blue nitrogen skies of Earth.
Yeah.
In one of his little speeches there that he liked to give. Um, Tell us about the learning and preparation that you've needed to do to get to this point, because you just described a number of 60-something lava tubes. I wouldn't even know where to go. Well, okay, I would go to class to start to see if I could get that from the Center for Lunar and Asteroid Surface Science thing, whatever it is. Daniel Britz, who I do have an interview with that should come out fairly soon here. Who have you partnered with, and what have you had to learn to get to this point where you're like, okay, we're confident we can go ahead and do this?
Right. Well, so for over 35 years, I've been designing and building, mission critical facilities, which are some of the most complex buildings that are here on Earth because there's redundancy in electrical and
Mhm.
mechanical systems that are structurally hard and things like that. So I had to learn the trade, and because I've worked within the architecture, electrical, mechanical, and civil engineering fields, I understand all those ideas and the timing of information and what they require in order to do what they need to do. So I've learned all that, and then I have a very creative imagination. Back in 1983, I developed my first robotic systems for designing very large structures in microgravity, and these are large enough to spin and create artificial gravity. So I was inspired by Dr. Gerard O'Neill, who wrote the book The High Frontier, and I couldn't figure out how he's going to build these things, with miles and miles of glass. I mean, how do you construct that? And so I came up with a different process. I'm constantly thinking about new and different ways of building things. So that was the first step. And then, the most critical thing in any kind of idea is to take it from an idea to something that's actually realizable. And in order to do that, you have to gather resources. Now, the lowest hanging fruit of resources is money, but beyond money, you need other things. You need really talented people that know other things that I don't know. And so I found some world-class space architects and lawyers, space lawyers, and financial people. I've also found, a couple of the country's leading roboticists for robots in space. And so, all these different people are going to be contributing things, and I had to go out and find them and cajole them and convince them that this is something that they need to get involved in. And that only continues. We're going to be, like I said, we're going to be doing sustainable food production. So I need to find people that can do vertical gardens, and I need to, develop cell-based meat production on the moon. And so there's a lot of things that I can't do. I can't boil the ocean myself. So I need to gather enough resources of many different types to be able to do that. And then once it reaches a certain critical mass, then there's really nothing that's going to hold it back. Once you have the money and the resources in place, it just starts to snowball from there.
Okay. Well, let's finish up with this then. Who are you looking to partner with? What kind of people are you looking to meet in organizations?
So partners are also possibly going to be tenants. So, obviously we want to look for miners, space miners. We're going to look for tourists. We're going to look for data center owners that want to have data centers. But we're also going to need other things in order to help that happen. If we're going to have data centers, we're going to need to have a data relay system. So we've been talking with Comstar Communications, and they're going to be putting up fairly soon a high bandwidth satellite system in L1 or L2, and be able to relay the information from the Earth to the moon and back. So, there's a variety of different partners that we need, but those are the easiest ones to identify at this time. As we progress, there's probably going to be many more we haven't even thought about yet.
Okay. Well, I like that you're very clear about, I don't know what I don't know, which is something that a lot of people have a hard time figuring out. So it's a great place to start from, be able to say, I don't know about that particular area. How can people get a hold of you if they want to contribute or find out more? Where's the best place to go?
So we have a website, www.united-space-structures.com. And there's a wealth of information there. There's a 60-second video that shows, the architecture and the kind of things that are going to go in it. There's the locations on the website as far as the locations on the moon that we're going to be building on. And that website is only going to continue to grow, as we develop. We've got other ideas for surface structures, and we're going to still have ideas for in space structures and unmanned manufacturing plants in low Earth orbit. So, this is just the beginning of a longer story. So
Great.
I would check out the website, and through the website you can always contact me and let me know how you want to help, or if you want to be a tenant, or if you want to be an investor. We're fundraising and will be for the next 6 years or more. So if you're an investor and you want to get in the space arena and you want to do something significant, contact me.
Right. This is it. And I personally cannot wait until we get some sort of orbital construction platform up there. I think it's a very necessary next step. All right, my guest has been Bill Kemp, CEO and founder of United Space Structures, and we'll have the link to the website in the video notes below. Thanks for being here, Bill.
Thanks. Appreciate it, Jason.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Start Project. If you want me to send you new episodes of the Cold Start Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Start Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks for listening, and I look forward to talking to you soon.